Welcome to video 28 of Gamer to Game Developer Series 1, and in this video we're going to implement water. So we're going to take the not so good looking Unity simple water and turn it into something that looks pretty nice and has transparency to it. So what we'll do is to first make a water plane, so something that looks like water when you're looking from above. Then we'll flip that water plane, change it a bit so that when we're underneath it we can see water as well. We'll see a water surface. Then we need to set up the effect that makes it look like that we're in a body of water, because it's actually just a plane. There's nothing actually below that plane. It's just a simple 2D thing. So we have to create the effect of us being in the water. So we'll implement a script that'll also take care of the amount of our camera that should be submerged in the water. And then, last of all, we'll implement our water behavior, so how our control should function while we're in the water. So our first step is to make the water plane, and it's going to look like something like this. We'll go for something very close to this, where our water has a nice color to it, it has transparency, and it has depth as well, in that the deeper an area is, the darker the shade will appear to be in the water. So you can see there the lighter looking areas are actually shallower portions of the water. So it's an interesting effect. Alright, so let's get started. Go over to Assets, Import Package, and import the water basic. Import everything. And then go over to your standard assets folder, and inside that there'll be water basic. You'll have here daylight simple water, that's what we'll edit. And there's the shader, and we'll just drag the simple water into the hierarchy. Change the Y height to 14. Change its scale in X to 2000 and Z to 2000 as well. Okay, so that's our simple water. As you can see, it's opaque and not very interesting looking. So let's open up the shader, FX Water Simple. And I'm still learning about shaders myself. But what we can do to make this look better is to just get rid of this bit here with tags. So in Subshader, tags, let's change this bit to Q. And there's no autocomplete, so we do have to be careful with how we spell everything. Is equal to geometry. And under pass, we'll add 3 new lines. So we'll write Z right off. This has something to do with allowing us to have a transparent sort of appearance. Then color mask RGB. And then blend 1, and then again 1 minus DST color. Okay. And you can read up a bit about shaders by going to the Unity Shader Lab documentation, and that's what I read to understand what roughly I need to be changing. So I just did trial and error and tried a couple of things and came to the result that I was after. So okay, let's save that and then jump back to Unity, and that's much closer to what I'm after. So we have there a transparent water. We can see immediately that it is transparent. And now the interesting thing is that this water, wherever it's deeper, it's darker there, which looks interesting actually. It looks like the water actually has depth to it. Okay. Now going back to that shader, I will just copy it over there. There are these other sections here, some for old cards, etc. We can just copy this over. So I'll just do the same for all these other sections, even though they're probably not needed. Okay, so that's it. Done all of them. Jump back to Unity. And let's edit our water a bit further. So let's change the horizon color. So for this, I'll set red to be 85. I'll set green to 170. I'll set blue to 205. So look, it looks much brighter now. It looks livelier. So you can change that to whatever you like, but I have a personal preference for this color. So I think that looks pretty nice. Now we'll do something more. I'll just change the name of this. So instead of daylight simple water, I'll just call it water. And that's pretty much it. So that's for the upper surface. So if I go down, you can see that there's nothing there. You can see right through the plane because it only has one side. So what we need to do is, in the next step, we'll just duplicate this plane and make an underwater surface as well. Now, the bit there about you saw there, like blend, etc., that too, just have a read up on the documentation for it, and there are lots of different types. Well, not lots, but there's a couple of different types of blending, and basically I just tried each one till I came to the one I liked, which was this 1 minus DST color. Okay, so let's just move on to the next step. We're on to our second objective, which is to make the underwater plane, and this is what it'll look like. So it'll be a deeper shade than what's above. Okay, let's duplicate the water. So just duplicate that, and I'll rename the duplicate to water upside down. So water upside down, and I'll duplicate the material as well. So we have here daylight simple water material. Duplicate that, and I'll rename the duplicate daylight simple underwater. So daylight simple underwater. I will also duplicate the shader here, FX water simple, and I'll rename the duplicate FX underwater simple. So underwater simple, yep, okay. And now let's open up the shader, this new shader, well, the duplicated one. And the first thing that we need to do is to change this title up here so that it matches the file name. So FX underwater, and that should be alright. I can leave the rest alone. Okay, now scroll down to the bit where we have tags, where we're going to change this again. And change the Q now to overlay. I should probably explain why I'm changing the rendering queue. Now this queue here, it determines what should get rendered first. So when I had queue set to geometry for our water on the top surface, what that means is that water is rendered along with other things like the terrain, but things like trees and their billboards are rendered a bit later than geometry. So they appear in front of things that have the queue geometry. Had I, for example, set the queue for my transparent water to be, say, transparent, then what would have happened is that it would get rendered on top of most other things, including geometry, which would be fine for geometry. You'd expect that, of course, the water would appear in front of that, but then things like tree billboards would not have a render queue such that they're drawn after the water. So what would happen is you'd get a really strange effect where you can see, if you're at a distance and you're looking at water and there are trees in front of water, like for example right here, what you would see instead is that the water would be in front of the tree, which looks odd. So that's why I've set the queue, the render queue for the water on the top surface to be geometry, and for underneath, so the underwater, I've set it to overlay. And if you have a look at the script reference, well, the shader lab reference, you can see that overlay is rendered. It's the very last thing that's rendered, so anything rendered last should go here. So I wanted that my underwater surface to be rendered last, so that way the water will appear in front of the trees, so it actually looks like we're underwater. Otherwise, had I, like, for example, set it to geometry, then once again the tree, even though we're underwater, the trees will appear in front of the water, which would look confusing again. So that's the reason why I'm playing around with this render queue here. Okay, so we'll leave Z-Write off, and we will change the blending here. It'll now be blend 1, and it'll be now source color, so SRC color. And I'll just copy this stuff over to the other sections as well. And same with our source color bit. Okay, we can save that and jump back to Unity. So we have our new edited shader here. We'll go to the material daylight simple underwater and change its shader type. So at the moment it's FX water simple, so let's go to FX, and here's our new shader. So FX underwater simple. So the title that we wrote back in the shader is very important for it to get recognized here. Okay, so that's our shader done. So our material added. So that's our material done. Now we need to assign this material to our water upside down. So let's change, whoa, and that's quite a lot of them. So that's our daylight simple underwater. Okay, that's good. That's the one we're after. And now we need to change the rotation. So let's change the X rotation to 180. Okay, and that's flipped it upside down. Now let's go underwater and see what it looks like. Alright, so it's really bright, and we don't want that. So let's change the horizon color, and let's change red to 40, green to 60, and blue to 70. That looks okay. Wonder about the alpha. Does that have any effect? No, it doesn't. Alright. So that looks like a fair looking underwater color. So I'm just having a look to see if I'm a bit satisfied. It does feel a little different in color to what I was expecting. I was expecting a somewhat deeper blue, so I could change that. I could use the slider, change the blue a bit. Yeah, I think that looks a little... I think more blue looks a bit better than less blue. So I might just... let me hit play as well, so I can see what's happening. Yeah, it looks pretty nice. I like how the waves we can... and as I was saying, you can see that the water is first, then the trees, which is very important. Otherwise it would look quite confusing. Alright. So I'll just stop that. That looks quite nice. And I'll just set that to 90. And there we go. Alright, so that's our underwater effect done. Now, we're not done yet, of course. We've got the illusion, basically, that there's a surface of water here. A body of water. But the moment if we're a player and we start walking into the water, well then, you know, we have a plane above and a plane below. So when we start walking into the water, we don't see anything. Like, it doesn't look like we're in a body of water anymore. So what we need to do is to just use a texture. We can just draw a texture across the screen that's a blue color and transparent, and we can change the fog setting so that it makes it look a bit like we're underwater. And there's another thing too as well. There's a bit of transition. So as we walk into the water, part of our camera will be, up in the sky, and part will be underwater. So I'll also have a script that allows the texture to be drawn only a part of the screen that's actually submerged in the water. Okay, so let's move on to that next objective. We're on to objective 3, which is to set up the submerged camera effect. So when should this underwater effect begin? What it is just a partly transparent blue texture that we just draw across the screen. But the thing is to note, just as I was just mentioning before, is that as the player is walking into the water, their camera will be partly submerged and then fully submerged. And what we can do is to draw our blue texture over the portion of the screen that is underwater. And the reason why we can do that easily too is that since we're using simple water, our water is just a flat 2D plane and there's no rippling like you would have with the Pro water. The amount the camera tilts affects how much of it is underwater. So what I'm trying to get at here is that we should focus on the camera to figure out how much of the screen is underwater. So whatever portion of the camera is underwater, that is the amount of the screen that the blue texture should be drawn over. So for example here, with the camera fully submerged, we draw the blue texture across the whole screen, the underwater effect across the whole screen. If the camera is partially submerged, then we only want to draw it across a portion of the screen. Now if that same camera, even though the height is the same, the player looks upwards, you'll notice that the camera now is less submerged, or if they look downwards, they're fully submerged. So we need to do a bit of a calculation to figure out the proportion of the camera submerged in the water. So this is it. So the proportion of camera underwater is the height 1 minus the water height, which is 14 meters in our case, divided by the height 1, the top of the camera, the viewing portion of it, minus height 2, which is the bottom portion of the viewing area of the camera. Now to achieve that, we're going to use some dummy game objects. We'll place one here and one here, and that'll give us the height values that we need for our calculation. And then we'll use this proportion. It's a percentage. Basically, if we times it by 100, we'll have the percentage of the camera underwater, and that is what we'll use to determine the percentage or the proportion of the screen that should be covered by a blue transparent texture. Okay, so our very first step will be to make that blue texture. Launch the GIMP and create a new 512 by 512 texture. And it's really simple, so layer, transparency, add alpha channel, edit clear, and then we'll simply use the paint bucket tool. We'll change the fore color to, let's see, a red 50, green 150, and a blue 255, and select OK, and just fill it in. Oh no, wait, thought I was forgetting something. Need to change the opacity 50%, so it'll be 50% transparent. Now we can fill it in. Okay, so let's save it. Our assets, textures, and I'll call this one screen water. Okay, so that's it with the GIMP, and if we jump back into Unity, we should have our new texture. And there we go, that's it. Okay, so we can move on to the next step. Okay, so we're on to our second step of objective 3, which is to implement the WaterEffect script. I'm going to start by setting up the reference game objects for our main camera. So go over to game object, create other, cube, and let's rename this cube. Let's call it camera top, and the name matters and the spelling of it because the WaterEffect script is going to look for this name. Okay, I'll get rid of the collider there, we don't need that. And I will change the scale, I'll leave X as it is. I'll change Y to 0.01 and I'll change Z to 0.01 as well. So it's just a thin rectangular object. And I'll change its position so that it sits just in front of the main camera and covers the topmost portion of the screen. So I'll change X to 0 because that's what our main camera is at 0. Well, mine is. Yours could be different. So mine is at 0, Y 30, Z minus 120. So I'll set camera top's Y to 30.06. And I will change Z to minus 119.89. Okay. And there we go, we can see it at the top of the screen. So that's our first reference object. And next I'll duplicate this and I'll call it camera bottom. And for this, I will simply change the Y value to be negative. Well, no, I won't actually make it negative. That's silly. I shouldn't make it negative. It should be 29.94. So it's 0.06. So basically our camera is actually a cube. Even though the camera is a game object that looks like it's empty and has nothing, the camera does actually have some dimensions to it. It's just not visible, that's all. So this is basically it. The width, the face of our camera is about 0.12 long, almost, maybe a bit more than that. That's why we can see these white bits, and these are close enough to the camera. So I'll just go have a look there. They're pretty close to the camera and should work good as guides, so we can change it if it doesn't work too well. And what I need to do now, of course, is to turn off the mesh renderer for both of them, and then I need to drop them into the main camera itself, and I'll do that for camera bottom as well. So now when the camera tilts or turns or whatever, these will always move with the main camera. And yes, now their positioning is relative to the camera itself. Okay, so that's good. Now we just need to attach our WaterEffect script to the players and the texture. So let's go to our players and drag our script in, WaterEffect. Add in our water texture. So there's a screen water. And repeat the same for the red player. Okay, we can save that. And let's give it a shot. Let's see what happens when we build this. I'll set up a server, join as a player here. Okay, and let's see how it looks. Does it work? And yes, it works. So we can see there that we have that partially submerged appearance, which you can see. Here's the blue texture being drawn, and here's the water surface that we can see on top. So here we're partly submerged. As we look up, our camera basically lifts out of the water, and as we look down, our camera is basically getting fully submerged. So it is working, and there we go. We can go underneath the water and everything is looking a bit different. Now, our controls need to change, of course. At the moment, we're just basically running around as if it were land. So I should probably go over the WaterEffect script. So for our controls, that'll be water behavior. That's the next objective. But for this, I should explain how this WaterEffect script is working so that our texture is only being drawn over the portion of the screen, as you can see, that is submerged. So the rest of the screen is basically unaffected. Let me just expand that. Yep, it's all good. Alright, so I'll just stop playing there. So open up the WaterEffect script, and I'll just briefly go over how it works. So as you just saw, this script is attached to the players and determines how the water texture should be drawn across the screen. We've got a couple of variables, some quick references here, the camera top game object, the camera bottom game object. Then we have some others that are used in drawing the water texture. So we have a water height. So our water system, of course, is based on a universal water height. I'm not using any colliders or anything fancy like that. I've kept it really simple. This is about as simple as you can get. Just having a simple water height to determine when the player is entering water. Then I have the texture, so this is the water texture was attached to that in the inspector. We have this float here called proportion, so that's the proportion of the camera underwater. We have a boolean submerge, it's just being used as a switch, and we have some other float settings here, so they're float variables, and they're all for our fog settings. So when we're underwater, the fog turns on, and so the trees in the distance basically will disappear. Okay, now all we do is just say when we in the start function, we just simply find the relevant game objects. We set the initial fog settings, so what the normal fog distance, etc. should be. On GUI, we then actually determine how much of the screen to cover with the water texture. So here I just perform that calculation. So when the player's Y height is less than water height, then just calculate that proportion just based off that very equation you saw in the slide earlier. So I'm taking the camera top's Y position, subtracting the water height, and dividing by camera top minus camera bottom, and that's very simple. Then if our proportion, so if the camera is not fully submerged, then I'd like to keep the normal fog settings, and I need to just draw the texture over the portion of the screen that is submerged, and that's very simple. So it's the top point on the screen to start drawing the texture is screen.height times proportion. So that is where we start drawing the texture basically. Well, that's the portion that we cover on the screen vertically, and then we have the texture stretch across the width of the screen and the height of the screen. And I've used scale mode stretch to fill to make sure that the texture fills all of that space. So that's basically it. This is what you're looking at that causes our texture to be drawn over a portion of the screen. Okay, now if the proportion is less than 0, that means we're fully submerged, and we just simply draw the texture across the full screen. Finish, simple. And I just changed these fog settings to be the water fog settings, which means that there's more fog basically. And if the proportion is greater than or equal to 0, then and our submerged is true, then that means our camera is no longer fully submerged, and we should set the normal fog distance. Okay, so that was it. That was pretty simple, which is good. And one thing I probably do need to do to going back into Unity, going to the render settings, is I probably need to change the fog color. So the fog color needs to be the color basically of the horizon. So let's go up, and change this fog color. I'll use the color picker tool. And just select the color of the horizon there. And let's run it again and see whether that color works. Okay, so that's our normal fog setting. It's working that much. And we can see it across the level as well, that the fog is being applied. Now let's jump into the water. It might be too bright. It looks like to me that the fog setting could be too bright. Then again, it might not be. So we can play around here basically. We can just see what the effect is if we change this color. So maybe try a darker color. It looks kind of, well, strange because now the trees aren't really hidden in the background. And I can make it lighter. I can make it darker. So the darker that we make it actually doesn't work so well because then everything starts being easily visible in the distance. So yeah, probably the original coloration was probably just fine for that. So I can just stop that and go back to the render settings, and the horizon color should be exactly what I had originally picked it as. Okay, so that's it. So that's it for fog settings, color, etc. We have so far all our underwater effects working. Now we need to actually implement the water behavior so that our controls are appropriate. We're on to our last objective, which is to implement the water behavior script. Okay, let's attach our water behavior script to both players. So I'll just drop it in. And also for our red player. And we can build and run. I'll set up a server here, and I'll jump back into Unity, make the window a bit bigger, and start a game here. Connect. Yep, doesn't matter which team. Alright, let's run into the water and see what happens. Alright, and I'm swimming. Basically, I'm not hugging the ground anymore, which is what the character motor script would make me do unless I press the jump key. And I can move in the water. If I let go, I'll slowly fall down to the ground. And I can just simply press up to swim upwards. And I can swim backwards too. I can teleport out of the water as well. So it's pretty easy, and it's working very well actually. So that's pretty neat. Okay, so I might just take myself back to shore, and let's have a look at our script. So the water behavior script, I'll open it up. And as we already know, it's attached to both players, and it governs their movement behavior while in water. So the script, it accesses the player stats script, but it does it actually access? Yes, it does. Of course it accesses the character motor script to change speed and gravity values. So we've got a bunch of variables. So we've got some quick references, transform, my transform, camera head, and to the character motor. We have some other, these two basically, this one's a switch, submerge, water height as you know is 14. Then we have here swim speed 2. This affects how fast we're able to accelerate while in the water, in that our speed is changed to 2, but we accelerate over time as we press the direction key, and as we accelerate we can then reach the normal speed. So that's how my water behavior works. We start at a slow speed and we have to, I guess, accelerate to reach the normal speed, and it feels like there's a bit of effort. So if you're in one direction, it just takes a bit to change the direction slightly. Okay, then we adjust our gravity as well. We have here normal gravity, water gravity, which is much lower, and the maximum fall speed is also adjusted. So normally it's 20. We're going to set it right down to 2. So if you're up in the air and you fall into the water, it'll break your fall basically. Okay, our start function, we set up our references. Here we get our normal speed, which is the max speed of the player. And then in the update function, so if the player is walking into the water, they're not currently submerged, but if their position decreases below the water height, now they're submerged. So the water conditions will apply, so like water gravity, swim speed, etc. Now, while they are submerged, we set motorscript.grounded to false. So this will mean that the player won't hug the ground anymore. And the space bar for jumping, it doesn't work anymore while they're grounded. They just need to press their direction key, and they will simply move in that direction. They won't try and hug the ground. So it's pretty simple. Now when the camera is above the water level, so basically the player is above the water level, then all we need to do is just go back to our normal settings, and we set submerged to false, of course. Now while the player is submerged, the controls are different, so now we have a bit of code for looking at the vertical axis, looking what's happening. So if the player presses W or S, then this bit of script will work while the player is submerged. And what it's doing is that so long as the player's velocity, the magnitude of that velocity, because remember velocity can be negative or positive, so you use magnitude, and it's also a vector 3. And this is a float, so this is a way to compare, use the magnitude. So long as the player's velocity is less than or equal to their normal speed, then we will apply this motion here, this adjustment to the player's velocity rather. So while they're below that normal speed, all we do is we say that whatever direction the camera is facing, then apply the vertical axis to that. So if it was forward, then it's just a +1. If it's backwards, then it's a -1. Then times by the normal speed, so whatever the player's speed is, times time.delta time. And note here I have plus equals, so it's the velocity, the current velocity, plus all of this. So we're adding to the player's velocity as we hold down our vertical axis key. So if I'm holding W down, I don't immediately start moving at a set speed. What happens is I will add to my current speed. So if I'm below this normal speed, let's say I'm 3 meters per second I'm moving at, and my max speed is 5, then this will keep adding to my speed until I reach 5. And so it feels like when we're in the water, it feels like that we start off slow and then we start to accelerate, which feels about right, basically. So that's it. That's the script explained. And I can just jump back here, and I suppose I can try it with another player. Oh, actually, I can't remember which team I joined. Oh, let me just try the blue team. It probably was the blue team, actually, now that I think about it, that I had jumped in as. And of course, it'll work for the red team, no problem. And you can swim up, down. Let me just fly out of the water, see what happens, come hurtling down, and I just gently fall to the ground, which is nice. And yes, of course, while we're underwater, we just simply hit the teleport button and we'll move automatically in the direction the camera is facing. That's just like how the controls are, which is nice. And yes, the fog settings, you can see that they are working in the distance, so when I come up to the surface it won't be so obvious, but which is a good thing. But actually the fog settings, they return back to normal when we're close to the surface of the water, and that was the other script, the WaterEffect script, that does that. Okay, so our water is working pretty nicely. It looks pretty nice, and our water behavior makes sense, and we're able to swim through the water. Our WaterEffect script is making sure that the texture for being drawn across the screen only draws across the portion of the screen that is actually submerged underwater, as you can see, which is pretty cool. And that's it. So our water video is complete, and in our next video there's something that you need to know, is that our explosion effects, because of the render queues of everything, our explosion effects etc. are not going to look quite right. So for example, if I fire something into the water, you can see that it looks a little bit, well, something not quite right. The particle effect, it'll look like, well, let me blow something up instead of me blabbing here. So I'll turn this off. Okay, and you can see that the explosion effect really looks like it's in front of the water. That's because it's being rendered after the water, because our water is geometry. So the blocks are geometry, no problem, the water appears in front of them, but particle effects, even if they occur underwater, they're going to look like they're in front of the water. So to counteract that, in the next video we'll just adjust our explosion effects slightly to just basically have a different color and appearance, and we'll alter our code a bit so that when something's under the water level, its explosion will look a bit different. And we'll do the same for the blaster as well. Okay, so that's it for this video, and I'll see you in the next video.